All right, so today's notes are on similar triangles and flowcharts. So we are going to have to talk about proving triangles that are similar. And so there are three different ways to do that. So the first method would be your angle-angle similarity theorem. And so if two pairs of angles have equal measures, then the triangles are similar. The second one is the side angle side similarity condition, and that means if two pairs of corresponding side ratios are equal and the included angle. Included is just a fancy way of saying the angle in between the two given side measures. So let's take a look at the corresponding side ratios. So the corresponding side ratios would be KA corresponds to side A, KB corresponds to side B. Now, if we were to reduce those ratios, A divided by A is 1, so we're left with K. B divided by B is 1, so we're left with K, because K times 1 is just K. And so now we can see that the ratio of corresponding sides are equal. So if you have two pairs of sides that have corresponding equal ratios, and then the included angles are congruent, that's when you can use the side angle side similarity. The last one is called side side side, and this is when two triangles are similar if three corresponding side lengths are proportional, or three corresponding side length ratios are equal. That's what that means. So, for example, if we were to take a look at this and throw some values on here, let's say AB is 10, DE is 5, AC is 9, DF is 4.5, BC is 8, and then EF is 4. So if we were to fill in the ratios that they have for us, AB is 10, which corresponds with DE, which is 5. BC is 8, which corresponds to EF, which is a length of 4. And then AC is 9, which corresponds with DF, which is a length of 4.5. Now, if we were to reduce 10 over 5, or 10 divided by 5 would give us a 2, 8 divided by 4 is 2, and 9 divided by 4.5 would be 2 as well. So because all of the side ratios are equal to each other, then we know that these are similar by side. You don't need to know this for this part of the quiz, but just a little reminder that this 2 is called the zoom factor or the scale factor, and that tells you how the figure is dilating, if it's getting bigger or getting smaller. So now let's take a look at example 1. Now for example 1, what we want to do is we want to set up a similarity flow chart to determine how the triangles are similar. Now, the three different ways that we talked about earlier are angle-angle similarity, side angle side similarity, and side side side. So there's only three different ways that you can prove triangles are similar, and these are your choices. Now, if you look in the pictures, it doesn't tell us any information about the angles. So right away, we can say that it's not angle-angle and that it's not side angle side. So if these are similar, they're going to have to be similar by side 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 similarity. So let's go ahead and write the information that we know. So we do know that the 9 corresponds with the 15. And if we reduce that, we will get 3. See, 3 goes into 9 3 times, and 3 goes into 15 5 times. So we know that 9 over 15 equals 3/5, so that's one pair of corresponding sides. Another pair of corresponding sides would be the 6 and the 10, because they're both the smallest sides. And so let's see what number can go into 6 and 10. 2. 2 can go into 6 3 times. 2 can go into 10 5 times. We know that 6/10 is equal to 3/5. And then our last pair of corresponding sides is 12 and 20. Now a number that can go into 12 and into 20 would be 4. 4 can go into 12 3 times. 4 can go into 20 5 times. And so if you take a look, all of these pairs of corresponding ratios equal 3/5. So because they have the same value, each of those ratios, that means that these triangles are going to be congruent by, similar by side, side, side. So triangle ABC is similar to triangle DEF. Okay, and then what you do is you write the reason for how you know they're similar, and so we would say side, 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 similarity. And so that is what a flowchart would look like. So now let's take a look at example 2. In this figure, it tells us that these two triangles are similar to one another using this similarity statement up here. And it says to set up a proportion and to solve for x. What I would like to do is show you the two different triangles that exist here. So you've got this purple triangle, which is the bigger one. And then you also have the blue triangle, which is the smaller one. Now, because of these arrows that you see, these red arrows are telling you that the lines are parallel. And so if lines are parallel, then corresponding angles are congruent. And so angle B and angle D from the blue triangle would be corresponding. Also, angle A and angle CED would be corresponding as well, so they're going to be congruent. So it doesn't ask you to tell us why these triangles are similar. I said congruent before, I meant similar. So if these, now we can prove these triangles are similar because of the angle similarity. Now, once again, it didn't ask us to tell us why, but I wanted to make sure that you knew that so that you could pick that out in the quiz you've got in your next assignment. So now the similarity statement tells us how these triangles are similar. So we want to find x, so I'm going to start with x. And so the x is your bottom side here in your triangle. And so then the bottom of the purple triangle would be this side, which is 8 plus x. And so we don't know what x is, so I'm just going to say 8 plus x is how you would get that length. And so then 8 plus x would correspond with that length of x. I don't know the length of BD, so that's not really going to help me. I do know the length of BA, and BA would correspond with the 4 of the blue triangle. And so I'm going to put the 4 on the top because it comes from the same blue triangle as the x. And then the 4 corresponds from the 12, which is from the purple triangle, which is the same triangle as the 8 plus x. So they're both going to go on the bottom. Now what we can do is we can cross multiply to solve for our x value. So we're going to want to do 12 times x equals 4 times the quantity of 8 plus x. Now you don't need to write that grouping, but I like to write the grouping to show you that the 4 is going to be multiplied to both of those values. 4 times 8 is 32, 4 times x is 4x. Now what we want to do is we want to get the x's to one side of the equation. Since 12 is bigger, I'm going to subtract 4x and put that on one side. So this gives us a big fat 0. And then we're just going to bring down our 32 equals 12x minus 4x would give us 8x. Then we can divide by 8 to show that x is 4. And that's how you would find your value of x. This, I believe, is the same problem that was found in your e-learning assignment too, if you wanted to go back and take a look at that. So now we have one more for the notes. This is example 3. We don't need to know this, but I like to point out to you that whenever we've got vertical angles, we automatically know that they're congruent to one another. Vertical angles are always congruent to one another. And I forgot to make one of the sides x, so I'm going to do that now. Let's just say this side was x. And then let's solve for that length. I know you know it's 6, but let me show you how we would find it if BC were x. So let's find the corresponding sides. So x is the BC, and if you look in the similarity statement, BC is the last 2 letters, and so is DC. So that's how we know that those are going to correspond with one another. So x corresponds to the 10, And then the other two lengths that we know is going to be the AC is 12. And so in the similarity statement, A and C are the outside letters, so EC corresponds with AC. So I'm going to put 12 on top since it comes from the same triangle as the X, and then the 20 on the bottom since it comes from the same triangle as the 10. And now we're going to go ahead and cross multiply. So we've got X times 20, which is 20X, 10 times 12, which is 120. And then we're going to divide by 20 to get X by itself. 20 divided by 20 is 1. 1X is X. 120 divided by 20 is 6. And there you have it. The X is a value of 6. All right, so what I'd like you to do now is try your assignment in Class Kick. If you have any more questions or you would like this explained to you again, feel free to rewind the video to watch it again. Also send me an email or a remind text if you're struggling. You can always raise the hand as well to either check your work to let me know that it's done, or just raise it if you have a question. Have a good day, guys. Talk to you later. Bye.